Question number 5 says use the sum and difference of cubes to factor each binomial over the set of real numbers. Remember, I'm just going to tell you to factor. How do you know when to use the sum and difference of cubes? There's a couple of reasons why. You only have a binomial, 2 terms. And then the second condition is if you added a placeholder, x to the third plus 0x plus 125, half of 3 is 1.5. This is 1, so you cannot use the x box of factoring. So another way to know you're going to use this method is if you could take the cube root of each of these. There, x times x is x cubed, and 5 cubed gives me 125. This is my a, this is my b. I'm going to plug that into the formula. It's always going to be a, b, a squared, ab, b squared. And then I'm going to use SOAP, same, opposite, always positive. I'm going to do my substitutions. My a is x. My b value is 5. There, this is x squared. This is going to be a minus. This is going to be x times 5, which is 5x. And my b value is 5, so this is going to be 25. How do you factor x cubed plus 125? You use the formula, and then this is your answer. Let's do the same thing for question number letter C. I'm going to see if I can find the cube root. Class, what number are we going here? X squared is correct. Remember, when in doubt, write it out. When in doubt, write it out. That's 3x squared, and remember x squared is just x times x. So there you have 6 x's. And the cube root of 8? 2. So in this problem, my a value is x squared, my b value is b. Now, in this problem, the negative sign is not negative 2. This here is just telling you how to do the SOAP. Let's fill it out. And this one I'm going to take a little bit longer to do because you have the x squared. So my SOAP, same, opposite, always positive. My a value, b value, a value squared. So that means x squared times x squared, which would be x to the 4th. A times b, so that would be x squared times 2, so that would be just 2x squared. And your b value is just going to be 2. 2 squared is 4. Always, in the sum and difference of cubes, the second part of the problem, the trinomial here, this is always prime. You can never factor that. It'll always be prime. So, do you have a, b, and c? If you made there be a placeholder, you can take half of it. If you can't, that means you can't do x box. And if you could take the cube root of both of those binomials, then you have a sum and difference of cubes problem.